This is the IKococater DC power supply, 120 volts, 3 amps. You can see that here. It is the C123, Certainly if it was a 3010, it would be 30 volts, 10 amps, but it's 120 volts max, 3 amps. This is what the box looks like. I've already opened it. This is what you're going to get. It's pretty well packed. I really like the way it is. As long as the walls of the box, it's fairly thick cardboard. Take this out of here. You get the two ends on here. One of these has the L-shaped cutout for the controls, and it has also little cutouts on the bottom for where the feet are. You can see that there. Same thing on the other end. This one here just has the cutouts on the bottom for where the feet go in. So there's that, and you'll get yours wrapped in a piece of plastic. There'll be a tape on the end of it. Put all of this away here, and really the only other thing that it comes with is a kettle cord. So you'll get, they call these, some people call these kettle cords. It's literally, I think they call this an IEC power connector. So let's plug this in. I have to see it to get it plugged in correctly. There we go. Have a look-see at it. So power it up. 100 volts, 3 amps. So this one has the push button thing. So you push the button to get to the various digits, and you set them individually. Same thing with the maximum current. When you turn it on, you get this. This is a very bluish green light, as opposed to a more warmer green, if you will. Then you have your CV and your CC connection. Let's get this on the bench. This, I will tell you, is white labeled. I think that's obvious to anybody looking at one of these things. There are a zillion and 10 of these, and they are all essentially the same. And I'll show you that in a little bit different segment of the video here. Actually, the next segment I think I'm going to show you. I will also tell you this, that of all of the people who are white labeling these things, there's various brands that you get the brand on it. It's just a different plate with a different label. What matters about that is that depending on who is distributing this particular unit, you may or may not get good support. I will tell you that I have contacted these people, and they are stellar. So if you want one of these switching power supplies, a variable bench power supply, this is a very inexpensive unit, especially compared to some of the other stuff that you might get. I guess I don't have my power supply. It's back behind me. This is a good unit to start with. We're going to see when we get down to the bench what it does, what it doesn't do. If you're working with Arduino, if you're working with, you're not doing RF stuff, if you're not doing radio, high frequency, 2.4, that kind of thing, this will be a good power supply for you. Especially if you're starting out and you don't have any power supply at all. This is really way better than you could do. A lot worse than this. And these guys here, I will tell you, they are good people to work with. So, IKococater, yes, IKococater, with the K starting. I like these people. So let's go take a look at this, and just to show you how very, very similar all of these various power supplies of this form factor and design are. So you can see that these are all very, very similar, just even in appearance. This one in front here is a 30 volt, 10 amp, and the two in back here are both 120 volt, 3 amp. And really, the only difference is, there's very little difference in what these are internally. The circuit board layout controls. So they have a plastic control panel. This one here is one that has push buttons on it. So you have a digital encoder knob. You have two knobs. Each of them is a digital encoder, and you select which digit you want to set. This one here has, instead of digital encoders, this has potentiometers, a coarse and a fine for each one of them. But the boards are, the whole thing is really similar. The back end of it here is where you've got your cooling fan, and you got your power connectors, combination fuse connectors there. Same thing with these here. This other one, and I'll just move this kind of aside here and show you. You got your same exact thing. So these panels are actually somewhat interchangeable. Circuit board configuration is almost identical, and then you'll see that there's just a flat heatsink back here. There's no fins on it. There's no cutouts. Nothing. You'll see that the output transistors, the power switchers, are here. They're exactly the same. This is the 10 amp version, and this here is the 10 amp version, and these are the 10 amp 30 volt, and then this one here is the 120 volt 3 amp version. So they even have very similar, just everything is very similar. When you look at the pictures, and I'll have a picture of the capacitors here, they don't show you, you see a picture of but all of these capacitors are CHENG, Cheng. So I'm not familiar with that brand of capacitor. Certainly these are not Nishikon. They're they're not Panasonic. But it will do the job, and that's what we're looking for here. I'm looking to see if I can tell like any major differences here. Something that would account for, one being 10 amps, 120 volts, the other one being, something. But basically, what you're doing is you're just exchanging voltage for current in the same power profile. All right, so let's get these things on a bench, put them through their paces, and show you what they can do, what they can't do, what they're good at, what they're not so good at. There we go. It's 3 amps, 20 volts. If I turn the output on now, take a look at what we have on the scope. It's quite a bit different than what we saw with the linear supply. We're definitely getting some noise there. Not a lot. What I want to do here is I want to basically zoom out, if you will, and take a look at the signal here. I'm getting some spikes. These are really short spikes in terms of the time, and they're all over the place on it. But let's put a load on it and see what happens. So I'm going to bring this back down to 500 milliamps or millivolts per division. So here's what we had before. If I put a load on it, I'm going to put a 2 amp load on it at 20 volts. There's your 2 amp load. That's what it does. So you're definitely getting a lot more noise under load. I mean, significantly more noise. If I turn the statistics on here, hang on a second. Let's turn my statistics on. So what it's saying here is that I'm getting 700 and a mean of 760 millivolts of AC noise on top of my 20 volts of DC. Once again, we expect that with a switching power supply under load. So that's 2 amps at 20 volts. If I crank this up, let's see what happens if I go to 2.5 amps. So this 2.5 amps, really no change here. Let's crank this up all the way up to 3 amps. So this is, we'll just go all the way up to 120 volts. There's 120 volts at 3 amps, and it's doing its thing. It's 360 watts output. We should start. Yeah, I got the fan. I feel the fan blowing here on the power supply. Certainly the electronic load is going to go. We're at above about 85% of the capacity of the load there. So I think we're good to go. And I've already done this, just to say I've had this on the bench. I left it for about 3 hours, and it's fine. So Yeah, this is thumbs up. There's absolutely nothing wrong with this. The only thing that I don't like about it, there's a couple things I should say. When you turn the power off, if you had a unit that was energized and you wanted to turn the power off, watch what happens. You still have power coming out of this. So if you had something where the smoke was coming out of it, or you thought it was getting too hot, or there was a situation where we're still at 0.3 volts, which is not bad, but my point is that there's no relay on this. And not to throw shade to these guys here, the same thing is true with my linear power supply. The people who design these power supplies are not talking to me. So also I should say, what novel things can you do with a 120 volt DC power supply that you couldn't do with something that only puts out like 30 volts or maybe even 40 volts? Well, for one thing, you can test neon lamps with it. If I do this, set it up to 80 volts, I got it at 82, doesn't really matter. There you go. So you can do that. Another thing that you can do that's just kind of novel, notice it doesn't go off right away. Another thing you can do that's kind of novel is you can take tip-on glass LEDs, LED strips. They would normally take more than 30 volts just to get them to light up. And you can test these with a power supply that has this much voltage. So if I turn this up to, this is probably going to be more like 60 volts. Can't remember the exact voltage that these things want, but if I put this on 60 volts, then I can do this. There, it lights up. One last thing you can do if you happen to have two of these, you can actually hook them up in series. And we'll get 240 volts. You'll see over here, it'll say 240, I'm guessing. So there's 120 there, 120 there, and now we are looking at 240 volts across the two.
This review is for the IKococater DC power supply. This is the 60 volt by 5 amp unit. Right now I have it powered up. What I'll do is I'll turn it off, so you have two on-off buttons, and it takes a little while for it to actually drain the capacitors, I'm assuming. And then you can see it's completely off. Right now everything is dead. No current to the two cables. No current to the 5 volt 2 amp outlet here. What you have to do is you turn this thing on, and I have a linear actuator that I'm going to show you, working with this thing. Nothing special. I don't do anything all that crazy. I like to mess around with electronics and repair stuff if I can, and build digital or build synthesizer kits and mess around with Arduinos and stuff like that. So I just needed something that a reliable power source that I could control the voltage and the amperage. This thing fits the bill perfectly. So in this state with this power button on, you can see the display. Right now it's telling you that the unit is actually off. This 5 amp or 5 volt outlet, USB outlet, is powered right now. Even though this says off, you can get power out of this right now, but you won't get any power out of these cables at this time. In order to do that, you would need to hit this button here, which you can see highlights green, and then the wattage goes to 0 because there's no draw on it right now. So I'm going to turn it back off. For this linear actuator, it is a 12 volt unit, and the paperwork basically says that its optimum range is about 5 amps. So what you have to do is, these are also push buttons as well as dials, but it allows you to, that blinking number is the one that's actually being changed right now, and you can see that you can, by the button press, and it's a little weird sometimes, like it did the last time. It shuts off, it doesn't allow you to change, but at this point it's on that first digit. So what I can do is I can just adjust this to 12 volt, and I could have actually see, let me drop this down to 12, I did bring my multimeter here, so I'll show you what you're actually getting out of it. And then I'm going to turn this down to 3 volts or 3 amps. And it'll stop blinking, so it's on. So it's set to that. It's not on yet. What I'm going to do is I'll show you. We'll clamp these to the multimeter, and hopefully you can see that. I believe you can. And now we're going to turn it on. We can see that it's counting down there. I'm not exactly sure what that is, but as soon as you turn it on, this is what you'll wind up with, slightly under the 12 volts. And as you go up, you can see even at 22 volts, you're actually getting 21.7, just fine. I don't know if all power supplies work that way or not. I have no idea, but I don't care. I'd rather it be slightly lower than whatever it is that I'm setting it to. So now what we'll do is we will hook this up, and this being closed, the connectors actually have to go to the opposite side of this. And I just got this power supply just to tinker around with things, mess around with things, and have a reliable power source that I could set and use without a problem. And this thing, like I said, does well. So I'm going to turn this on, and you'll see the actuator start to go. All right, you can see the wattage draw, what the amperage rate is. And then what we'll do is we'll stop it, and then to pull it back in, you reverse these. And when it hits, at the end, it'll automatically shut off, and you should see it there and what it's doing. And if it has a load on it, obviously it's going to use much more amperage there, but you can see it turns itself off. So just an example of what it can do. If you're looking at power supplies, I'm sure you have some general, at least a general idea of what it is that you're looking for. I could have easily gone with the 30 volt 10 amp unit. I just chose this, not really even thinking of much, but this will do exactly what I need it to do for most of the stuff that I plan on doing with it. There's not much to it. I don't know what else to say about it. There is a ground lug here, and I believe they are labeled underneath. You can see there's only the 2 cables included, and these are basically similar to, I guess it is a banana style plug, what they would call a banana style plug that just slips into the front. It's pretty tight and does the job. These are also screw terminals, so you could easily put a fork terminal or a ring terminal or something on the end of that if you needed to use the ground. This here is just the tag that covers the screen. I usually leave those on unless there's it looks like crap, then I'll take it off. On the back of the unit, you have a fan. I assume only comes on when it's high amp draw. I haven't gotten to that point. You have the power plug, and then below the power plug, you have the fuse. Not exactly sure. I believe you have to pull this out and then pull this little housing out, and then you have access to the fan, or to the fuse. And to turn the thing off completely. Right now it's off, so it's not putting current out, but it allows you to adjust the settings. To turn it off completely, you just push that button. It takes a second for it to drain the capacitors, and then it's done and over with. It doesn't weigh much, doesn't take up much space. You're looking at maybe a little less than 3.5, 3 3/8 by about 6 inches high, maybe about 8.5 inches deep, not counting the power plug or the 2 plugs sticking off the front. It's small enough to fit on my bench, and that's exactly where it's going to sit, because I am constantly trying to power up things, and test things. So I always have a need for it, and right now I've been using little power packs and stuff like that, and shady stuff that I don't want to get electrocuted with or burn something up. So this will definitely save me from that. It does have an after sales service. I have not had to reach out to them, so I don't know how the service is. The case is metal, sheet metal. I did not take it apart. You can see somewhat down inside there. I believe they have pictures of the inside of the thing on their website, and I have no reason to open it at this point. But definitely fits the purpose that I need it for. I'm not looking for anything crazy. This is all the features that I need. That's it. Hope this helps. Thank you.